Hi. Okay, so we're on 13.4, using technology to conduct a simulation. There's a couple of different ways that it wants us to do this, excuse me. We can, if you have Excel, you can actually go into it and do equals rand between. Do you see that? And then it'll pop up the bottom and the top numbers. And let's say I want 1 to 10. So then when I press OK, it'll give me a number there. And every single time that I move it, it gives me a new number. Pretty cool, huh? We can do the same thing that we had the previous time, where we were on randomlists.com/dice, and we can do it over there like that. You can also generate random numbers in your on your calculator. The code for that one they talked about in the previous section, I do believe. You tell it to make random, you tell it to do the random one the way that your graphing calculator or scientific calculator understands how to do randomized numbers. For today, for what we're doing, however, I am just going to be using the dice roller, I do believe. Okay, so on page 417, it is talking about a cereal company having a contest. There were codes for winning prizes in 30% of the boxes. So what it was trying to do is figure out how many boxes you would need to buy as a customer before you would actually manage to get a prize. It decided, because 30% is equal to 3/10, that the winning codes would be numbers 1, 2, and 3, and the losing codes would be numbers 4, 5, 6, 7, 8, 9, and 10. Because since this is a randomizer, you are just as likely to get a winning code as you are to get anything else. No number is more likely than any other number. All right, so let's go over to number 1, which is on page 418. It says an elephant has a 50% chance of giving birth to a male or female calf. Use a simulation to find the experimental probability that the elephant will give birth to 3 male calves before having a female calves. It says to use zeros and ones, with 0 representing the male calf and 1 representing the female calf. Here's the thing though. Since I'm using the random dice roller, I'm actually going to use 1s and 2s. I'm not going to do 0 and 1. I'm going to tell this that it has 2 sides, and I'm going to get like 10 dice. Okay, that's my first one, second one, third one, fourth one, fifth one. You see the itty bitty little number next to it? That's what I'm doing with the numbers. All right, so give me a second to type in my, actually rereading this, all I need to do is do 4 of them. I don't need 10. I misunderstood the question. I only need 4. So we had decided that the male was going to be 1 and the female is going to be 2. So I have 1, 2, 2, 2. That means we did not have 3 males come first. Let's try it again. This time I have all girls. So nope, didn't happen. Let's try it again. This time I start with a girl, and then I have 3 boys. So nope. This time I start with a girl, I have 2 boys, and I end with a girl. This time I have 2 boys, then a girl, and then another boy. This time I have girl, boy, girl, girl, whoops, girl, girl. This time I have girl, boy, girl, boy. This time I have boy, girl, boy, boy. This time I have boy, girl, girl, boy. And this time I have girl, boy, girl, whoops, girl, girl. Did I ever end up with 3 males first? No. So my estimated probability of getting 3 males first was 0%. There was no chance whatsoever of getting 3 males first in this particular one. You'll notice I did have one scenario where it was 3 girls, but then I didn't have a boy at the end. And here I had 1 boy and then I had 3 girls. Here I had 1 girl and then I had 3 boys. But I did not get a single one where I ended up with 3 boys and then 1 girl. So that's kind of interesting. Okay, second one, conducting a simulation for a compound event. You can use random numbers to simulate the compound events as well as simple events. So this time they are looking at how many eruptions you can expect. I'm on page 418 to 419, by the way. If you're assuming that an eruption occurs every time that you get to a 1. So each decade has a certain number of, oh, I guess this was supposed to be all zeros. There you go. An eruption decade. So let's go down to number 2 at the bottom of 419. I'm going to erase this information because we don't need it. We still have 10. And I'm going to change this to correct answers. Now, what are our options? We need to know what the options are so we know what to do over here on the dice roller. It says Matt guesses the answers on a quiz with 5 true-false questions. The probability of guessing correctly is 50%. Use a simulation to find the experimental probability he gets at least 2 of the questions right. So I'm going to have 1s be incorrect and 2s be correct. So 1 equals incorrect, 2 equals correct. And how many are we doing? 5 points. So I need to add in 1 more die. So now I have 5 die. Okay. And my numbers that were generated, 1, 2, 2, 2, 1. How many correct? 3. Roll it again. 1, 1, oops. 1, 1, 2, 1, 1, 2, 2. 2 correct. Roll it again. 2, 2, 1, 1, 2, 3 correct. Roll it again. 1, 1, 1, 2, 2. Whoops. 2 correct. 2, 1, 1, 1, 2, 2 correct. 2, 1, 1, 1, 1, 1, 1 correct. 2, 2, 1, 1, 2, 3 correct. 1, 2, 2, 2, 1, 3 correct. 1, 1, 2, 2, 1, 2 correct. And finally, 1, 2, 1, 1, 2. 2 correct. So our question was, how often would he get 2 correct? Right? 2 correct. Okay, so every time except for this one time, he got at least 2 correct. So that was 9 out of 10 times he got 2 correct, or 90% of the time he got 2 correct. I don't know that you would want to get 2 correct out of a 5-point quiz. You only get 2 of them right, because 2 divided by 5 equals, well, I guess it's not going to show us. All right, do I even have a calculator? Just a second. Yeah, so 2 divided by 5 is a 40%. That's not even passing. 3 divided by 5, which looks like the best that you could possibly hope for, is a divided by 5 is 60%. And that's just barely above failing, and you only have a 1, 2, 3, 4. You only have a 4 out of 10, or a 40% chance of getting. Did you see that? Decided that, oh, I must be talking about, I'm not talking about the date. There. You don't write it that way. Which is 40%. So, yeah, so this isn't even the one that you're most likely to get. You're far more likely to get at least 2 correct than you are to get at least 3 correct. And this isn't even that great of a score. And look at that. You have 1 chance of getting an even lower score than 40% on your final. So maybe not the best way to go about it. All right, so let's see what we got going on over here in the guided practice. I am now on page 420. There's a 30% chance that Tashana's country will have a drought during any given year. She performs a simulation to find the probability of a drought in at least one of the next 4 years. Tashana's model involves the whole numbers from 1 until 10. So 30% chance, that's 3 out of 10. So numbers 1 through 3 are when there's rain. Okay, so 1 through 3 is when there's rain. There is rain. The numbers 4 through 10, so if 1 through 3, there is rain. 4 through 10, there is not rain. So let me delete all of this. So 1 through 3 equals rain. 4 through 10 equals no rain. Okay, so that's what we have. Perform multiple trials, generating, how many years do we need each time? We need 4 years each time. Suppose that Deshauna used the model described in exercise 1 and got the results shown in this table. So, oh, I'm sorry. I messed that up. So 1 through 3 is no rain. 4 through 10 is rain. We're looking for when there's a drought, not when there isn't a drought. Oops. Let's look at the numbers that she has. 10, 3, 5, 1. So how many numbers do I have between 1 and 3? 2. For trial number 2, how many numbers do I have between 1 and 3? 10, 4, 6, 5. None. For number 3, how many numbers do I have between 1 and 3? 3, 2, 10, 3. 3. Number 4, how many numbers do I have between 1 and 3? 2, 10, 4, 4, 1. Number 5, 7, 3, 6, 3, 2. Number 6, 8, 4, 8, 5, 0. Number 7, 6, 2, 2, 8, 2. Number 8, 6, 5, 2, 4, 1. Number 9, 2, 2, 3, 2, 4. Number 10, 6, 3, 1, 5, 2. All right, so now what are we supposed to do with this? According to the simulation, what is the experimental probability that there will be a drought in the country in at least one of the next 4 years? So 1, 2, 3, 4, 5, 6, 7, 8. 8 times out of 10, which is the same as 4/5, or 80%. You want to number 4, essential question. You want to generate random numbers to simulate an event with a 75% chance of occurring. 75% chance of occurring. What type of model could you use? Well, 75%. That is 3 out of 4. So it's quarters. 25, 50, 75, 100, $1. Yeah. 3 of them is 75. So that's 3 out of every 4. So we're looking at, if I use the numbers 1 through 4, 1 through 3 will be the result I want. 4 will be the result I don't want. Then I can randomly pick those in trials to see how often I get what I want. It's a weird way of explaining it. Okay, so that takes us to the independent practice, and I think you should be able to do it yourself. You should be good on it. They already have all of the random numbers, and you just need to sit there and see whether or not the number, how many times the number that we're looking for pops up. Okay, so remember, sometimes there's a range, like right here we have a range, and sometimes it's just the one number that we're looking for. So pay attention, read carefully, you should do just fine. Talk to you later, guys. Bye.